So this question looks like it's going to be a translate word problem question. So let's read it and see if there's anything to write down here. So the question says a hot air balloon 70 meters above the ground is falling at a constant rate of 6 meters per second. So let me just translate that. So I have 70 meters, but then it's going to go down. So I'm subtracting 6 meters per second, right? So I'll just say 70 meters and then minus 6 meters per second. And then I have another hot air balloon that's 10 meters above the ground, so it's at 10. And it's rising at a constant rate of 15 meters per second. So I'm going to add in 15 meters per second to my 10 meters. To the nearest tenth of a second, after how many seconds will the two balloons be the same height above the ground? So, how would I figure out the height of this first, I'll just call it balloon one. How would I figure out the height of this first balloon? Well, I like this equation or expression that I've written. I would have to multiply this by some number of seconds, right? So like, let's say x, and that'll give me the height. The same thing with balloon 2. I multiply it by the same number of seconds, or x seconds, and it would also give me a height. And then I'm looking for these two things. I'm looking for the x value for when these become equal to each other. So that's the game. I am going to use plug-in answers to play this game because, again, one of these answers here is the correct answer. So if I plugged in answer choice A of 8.9 being my x, let's see what happens with that. So 70 minus 6 times 8.9 and 10 plus 15 times 8.9. Let's go to my calculator and see what I get. I get 16.6 for that one. And then for the second balloon, 15 times 8.9 plus 10, I get 54.5, right? So these are not equal to each other. So A is gone. Next, same thing. I'll just plug in 6.7. So 6 times 6.7, and then 70 minus that. So I'm getting 29.8 is where this balloon ends up. And then for the 15 times 6.7 plus 10, I'm getting 110, right? So 110.5. So that's also not correct. When I try choice C, same exact thing. So 70 minus 6 times 2.9 and 10 plus 15 times 2.9. So 6 times 2.9 and then 70 minus that. So I end up at 52.6 and 15 times 2.9 plus 10. I end up at 53. 52.6. I end up at 53.5. So that's very close, right? It's not the exact same. It's very close. I'm not going to cross it. I'm going to leave it. So let's try these last two. So 70 minus 6 times 0.4. Which means it's only gone down to 67.6. And 10 plus 15 times 0.4. It's not going to be anywhere close to what I need it to be. That's only going to be to 16, so that's definitely out. And then 0.2 is even smaller than that, so that's also going to be out. You could try that on your own, but that'll also be out. So 2.9 seems to be the best answer here. I didn't get exact numbers here, so let me just check back to the question to see if I misread anything. So to the nearest tenth of a second... Oh, I see. So the nearest tenth of a second, if I were to round this to the nearest tenth of a second, if I round it to the nearest second, it's 53 for both of these. How many seconds? Yeah, so I don't know. I think that I tried the strategy. C is the only one that gives me two extremely close values, so it has to be the best answer out of the bunch. Again, you're always looking for the best answer, right? So in math, it's a little bit different than the other sections. There tends to not be as much subjectivity in math as there may be, like in the reading section, for instance. However, you are always looking for the best answer out of the options that you have, and for us, in this case, choice C is the best answer.